Good morning and welcome. It is Thursday, October 15th, 2020. We're going to be introducing Chapter 2 today. Specifically, we'll be talking about and z-scores and also cumulative frequency. We'll get into it. No stress. It'll be great. So, as usual, if you have questions, comments, concerns, anything you need help with along the way, raise your hand, unmute your mic, or type it in the chat, and I'm happy to assist you. First, we're going to talk about percentile. The percentile is defined as the pth percentile of a distribution is the value with p% of the observations less than it. Percentiles are one way to describe the location of a value within a distribution of a quantitative variable. All right. We don't really use percentiles for categorical variables because they don't have specific locations as numbers do. All right. So in a percentile, hopefully you've seen percentiles before in previous math classes. I know that they are covered in Math 1 and I believe in Math 3 again. If you haven't, for some reason, it's okay. Don't stress. We'll figure it out. We'll get it done today, right? So if I am at the 25th percentile of a distribution, that means that 25% of the observations have a value less than me. If I'm at the 75th percentile, 75% of the values are less than me. So a percentile tells you what percentage of your observations are less than that. It is a key point. If you want to know who has like my score or higher, that would be 100 minus the percentile, right? So if I'm at the 75th percentile, that means 25% of the observations have my score or higher. 75%, which is the percentile, is less than my score. All right. So again, we're going to look at this example here. All right, our STEM plot here. To the left shows the test scores of 25 students in a class. I want to figure out what percentile is the student who scored an 86. All right. So let's look at our example. Come on, where's my pen? Where did the red go? Black. All right. So here we are. 86 is represented by this number right here. Right? The 8 here and the 6 here. Right? So we need to see how many numbers are less than 86. Not equal to or less than, only less than. So I need to count up how many numbers are less than. Let's change our color. Go to that one. Right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and I stop. I do not count 86. Because again, I only want the values less than 86. So I have 21, blackjack. Right? I have 21 observations that are less than 86. All right. So there's 21 scores, right? Less than 86. Again, we're looking at less than. Okay, so now I need to find the percentage. To do that, I take the scores that are less than 86 and divide by the total number of scores, or the total number of observations. Why this pen's being all janky on me right now. So 21 divided by 25. And that's going to get me a decimal, which is 0.84. So this is just the decimal. I can convert this now to a percent. Okay, we have to convert to a percent. When we do that, I always just think of it as I move the decimal place 2 spots to the right, or you can think of it as multiplying by 100. They get us the same place. This converts to 84%. Right. So this means 84% of my scores were less than 86, which means this student is at the 86th percentile. Scored in the 84th percentile. So when we talk about percentile, that number is not given as a percentage. It doesn't have the little percentage sign. It is just referred to as the somethingth percentile. So this is the 84th percentile. That's where the score is. Okay, what questions do you have? Right. Anyone need another moment to write anything down from this screen? You. Okay, okay. Next. This is a whole kind of mess of words here, but we're going to see an actual example of what this is in a moment. So now we're going to talk about the cumulative relative frequency and graphs of that. Right. To get a cumulative relative frequency, you first need the relative frequency, which is a percentage, then the cumulative frequency, add the counts in the frequency column for the current class and all classes with smaller values of the variable. Lastly, find the cumulative relative frequency by dividing the entries in the cumulative frequency column by the total number of individuals and convert to a percent. Right? This seems like a long and arduous process, but it is not that bad. Most of the work we've already done previously by finding frequency and relative frequency. Cumulative frequency and cumulative relative frequency are just the next steps in that. It's the next thing I can do with those numbers. Okay. Can you raise your hand if you need another moment to write this down? If you are writing down notes. All right. Then I shall pause and have some coffee. looks like we're ready. All right, so there's a lot going on here, but this will make more sense of our cumulative relative frequency and graph. So this table here and the graph here represent the ages of the first 44 US presidents when they took office. In this table, we have our classes, which are the age, 40 to 44, 45 to 49, 50 to 54, 55 to 40, 59, so on. Right? And then we have our frequency. We're familiar with this. Frequency is just the count of the number of things in those classes. We could use that to make a histogram. Our relative frequency, right? 2 divided by 44, because there's 44 presidents in our list, gives us 4.5%. And we know how to do this relative frequency calculation. We've done this previously. The new numbers are cumulative frequency and cumulative relative frequency. Cumulative means that it keeps adding up. So the first row is the same, right? 2 and 2, 4.5%, 4.5%. To get to the second value here, the 9, we take the 2 and add these 7 observations from the next class to get 9. Next row, we have 9 plus 13 is 22. 22 plus 12 is 34. 34 plus 7 is 41. 41 plus 3 is 44. So we're just adding all the numbers up as we go. So each row is a sum of all the previous rows before it and what it was already. So for the 55 to 59 class, the cumulative frequency is 12 plus 13 plus 7 plus 2. Everything in that class plus the things before it. The cumulative relative frequency works the same way, right? So it starts in the first row is the same, 4.5%, 4.5%. And then we use the cumulative frequency and divide that by 44 instead of just the numbers that were in that class originally, which would have been just 7. And we get 20.5. You can also think of it as taking the frequencies and adding them up as we go. 4.5 plus 15.9. Due to rounding for these percentages, that gets us to 20.4 and not 20.5 like this here. So if you want to avoid rounding errors or essentially propagating rounding errors as you go, the better rule is to use the frequency number and divide by the number of observations. You'll get a very close estimate by adding the relative frequencies as you go, the same way we did the regular frequency. And so that's how we build cumulative frequency and cumulative relative frequency. What questions do you have so far? Good. All right. So then when it comes to this graph, all right, to make a cumulative relative frequency graph, we plot a point corresponding to the cumulative relative frequency in each class at the smallest value of the next class. For example, for the 40 to 44 class, the point is plotted at the height of 4.5%, which we got from here, above the age value of 45, right, the smallest value of the next class, 45. So we have this right here. This means that 4.5% of presidents were inaugurated before they were 45 years old. So at this point, 4.5% of the presidents were younger than 45. So again, this 4.5% refers to how many values are less than where the dot is plotted at 45. Okay, so then we get all these points. Notice that we do have a point at the very beginning at 0 at the smallest value of the first class at 40. right? Which means there are no presidents of our 44 presidents in this sample that were younger than 40 when they took office or when they were inaugurated. Right? And so then we get this little curve that allows us to kind of see the distribution as a cumulative thing, right? Once we get up to 70, this should be 100%. If it's not, then we made an error somewhere. 100% of presidents were younger than 70 when they took office. There was no president that was 70 years old or older. Okay. What questions do you have? What can I clarify? Okay. All right. So the use of these cumulative relative frequency graphs is for estimating future values, so to say. These types of frequency graphs are used to show growth charts, like for children. There's this cumulative relative frequency curve that is used as a predictor for how many kids should be within a certain height or within a certain weight and things like that. So, in this case, for this example, if we have a president who's inaugurated when they're 62, we can use this as a predictor to say, okay, well, at 62, we're going to be about right here on this line, which corresponds to, maybe 81%. So we can say, all right, well, this president who was 62, they're at the 81st percentile. Okay, so 81% of presidents were younger than this new president when they took office. So we can then start using these as predictors of percentiles and location. Okay. Are there any questions? Okay. All right. So standardized z-score is another new term. And the definition is if X is an observation from a distribution that has a known mean and standard deviation, the standardized score for X is this formula, X minus the mean divided by the standard deviation. A standardized score is often called a z-score. Right? And what this does is it relates every value in our distribution to how far away it is from the mean, or how many standard deviations it is away from the mean. And that's really what this is saying. It relates things back to the mean and back to the standard deviation. Okay. So we're going to look at an example. We have our same set of data from the test scores of 25 students. All right. And we need the mean and the standard deviation. All right. Since I already did this in the last class, I already have this in my calculator. And so we found the mean. Let's pull this all over here. So we put all this stuff in our calculator, we made the list, added in our 25 data points, and then asked the calculator, hey, find me the values, right? We did our one variable statistics. We have an X bar or mean of 80 and a standard deviation, the S sub X, of 6.069047152. We'll round this to 6.07. Let's keep a couple of decimal places. All right? And that should be accurate enough for what we're doing. We don't need any of the other statistics at this point because we only need to do this calculation, the mean and the standard deviation. So that's all we're going to take from this. So we have 80 and 6.07. Right? So we have, let's write these things down. We have a mean, or an X bar, of 80. The average test score was 80. And the standard deviation, or S sub X, equals 6.07. So to find our z-score, we're going to do the same example where we're going to look at 86. All right? We want to see, okay, what's the standardized score, or z-score, for someone who scored 86 on this test? So we have z equals 86 minus the mean, which is 80, divided by 6.07. So that's going to be 6 divided by 6.07. And that lands us on approximately 0.99. The actual decimal is 0.988467874. Okay, we're going to round that to 0.99. So this number here says how many standard deviations the score of 86 is from the mean. And because this number is positive, it's a positive 0.99, that implies that this score is greater than the mean, and it's just one full standard deviation greater than the mean. Okay? And that obviously makes sense because 86 is greater than 80. If you get a standardized score that is a negative number, which will happen, like if I chose 67, I would get a negative number for the z-score. That means that the score of 67 is some number of standard deviations less than the mean. So it allows us to consider the location of each data point based on how far away it is from the mean in terms of the standard deviation. Which, if you recall from Tuesday, we can use that if something is more than 2 standard deviations away from the mean on either side, greater than or less than, that could be considered an outlier. So it allows us other ways of identifying and locating data points and how they relate to key statistics like the mean. Okay. What questions do you have? So, can you please raise your hand if you need more time to write anything down from this slide? Okay, so now we're going to move on to the next part of our presentation, and that will be an interactive part. So give me just a moment, I got to get that set up, and we'll get going. So I need to end that and keep that. Excellent. This one. think this. Put it this way. And try to paste. Give this a moment. We're going to do a pair deck. I'll actually be able to practice using the percentile. I think that's all we'll have time for. With some observation here. All right, so I am putting a link into the chat. And it should be there now. Please click on the link and log into the pair deck. Use your school email and password to do so. Right? If you're having any issues logging into this, please let me know. And we will start shortly. All right, I can see there are 6 people in the room so far. I know I have 31 students logged into class right now. So please log in. If you're having issues, tell me so I can help. Okay, Arlen. Up to 13. This is a great opportunity for you guys to practice and get feedback and get have it feel more like we're actually in a classroom. You can try these things with no risk. So please, please participate. It's going to be helpful. Ooh, up to 19. So guys, keep going. Keep joining. If there's problems, you need to tell me. All right. Well, we're going to start this. Seems like we've stagnated at around 19 students, so there's over 10 of you who just don't want to play, I guess. All right. So we're going to get started. So here we are. Where do you stand? This is an introduction to location and percentiles. This is interactive. You will have to type in answers and such. All right. So we're going to use the stem plot below to answer the question. How many students scored below a 72 according to this stem plot? You want to know how many scored below a 72, not 72 or less, strictly less than. We should not have negative numbers. Please, no negative numbers. Well, guys, this is an excellent opportunity to try, guess, give it a shot. And I see there's still 6 people who have not responded. Please guess. This is a learning opportunity. If you do not guess and you do not attempt, you are robbing yourself of an opportunity to learn. Right. Once again, we're just looking for how many students scored below a 72. All right. If you answered 1, that is correct. There is only one score listed in our STEM plot less than 72, and that would be the score of 67. It is the very first entry on our STEM plot. The 6th line, 7, implies a score of 67. The next score listed is 72, which means we only had one score less than. All right, yes, the score of 67 was the lowest. All right, next question. All right, so using the same exact STEM plot, all of these questions are going to use the same STEM plot. If James, the student, scored a 72, what is his percentile? The percentile should be a number between 0 and 100. In this case, there was one value less than 72. So when calculating the decimal representation or the percentage, we will divide 1 by the total number of observations, which is 25. That will give you a decimal. Move that decimal 2 spots to the right, and that will be your percentile. Ah, yes, I'm starting to see the response. Excellent. Okay. All right. for this, remember there's only one score, less than 72. So we take that 1, divide it by the total number of observations, which is 25. 1 divided by 25 is 0.04. We move that decimal 2 spots to the right, and we get 4. So 4% of scores were less than 72, which means 72 is at the 4th percentile. If you got a score or percentile of 8, you counted 72 and 67. Right? When you do percentile, you can only count the numbers less than the value that you're considering. In this case, you would only consider the value of 67. Right? Any questions? Anything I can clarify? Let's try another one. In this example, same stem plot, we have another student, they scored a 93. What is her percentile? And remember to first consider how many students scored less than 93. Do not count 93. We count how many things are less than 93, and then divide that number by 25. Yes, looks good so far. The hint is that it is not 100. Okay. All right. Go. All right. So the correct answer here was 96, or the 96th percentile. Right? 96% of the scores were less than 93. 4% were equal to 93 or greater. Okay. Remember, the percentile wants to know what percentage of scores were less than the value you're considering. We're considering the biggest value in our stem plot, which is 93, which means there's 24 numbers or 24 scores less than 93. So we take that 24, divide it by the number of observations of 25, and we get 0.96. Move that decimal spot 2 spots to the right, and we get 96 for the percentage, 96%, which means the score of 93 is at the 96th percentile. Okay. Let's try one more. So in this next example, right, 2 students scored 80. What percentile are they? Once again, remember to first consider how many students scored less than 80. Not 80 or less, only less than 80. Awesome. See a lot of correct answers. Very cool. All right. So in this situation, right, we have 12 scores less than 80. Right, the 2 scores at 80 don't affect how many were less than that. Right, so we have 12 scores less than 80. We divide that by 25. 12 divided by 25 is 0.48. Move that decimal spot 2 spots to the right. We get 48%, which means a score of 80 is at the 48th percentile. 48% of students scored less than 80. 52% scored higher than 80, 80 or higher. Okay. What questions do you have? What can I help clarify? Good. Okay. So I'm going to end the pair deck. We're stopping here. And I'm going to briefly review what we have left for the week as far as assignments and such. So, end that. Do that, and so, yeah. Okay. Can you guys see my screen again? Yes, yes, maybe. I'm hoping yes. No one's saying no? Yes. Aha, thank you. Thank you, thank you, thank you. All right, excellent. I love the confirmation. Appreciate it. All right, so here we go. We're in week 8. We're on Thursday. There's one discussion board for today. It's what's the percentile. You'll definitely use what we did today in class. I'll update our live class resources shortly. The major thing going on this week is the Chapter 1 self-assessment. You know, we finished Chapter 1 on Tuesday. The self-assessment is now available. Quick little preview. Okay. The free response portion, or the demonstration of understanding portion on this, has 2 parts. One having to do with categorical data and one with quantitative data. I didn't want to have to choose one or the other because they're both important and we need to know how to do both of them. So for this problem, the 2 parts, it might be easiest to kind of do it on a piece of paper, right? Kind of get all your work done, and then just attach, you know, upload a picture in for the response. You can use any technology you want to help answer these questions. You can use your graphing calculator, you can use Staplet, you can use Desmos, you can use whatever you're comfortable using to help get all of this put together. But I want to see your work, right? So I think the best thing to kind of put it all together might be to just write it by hand and take a picture, because it's going to be hard to get all of those things maybe into the text entry. You can, if you want, you totally can. You know, you can embed pictures into the text entry here, and you can get it all if you really want to. It might just take more time and effort than if you just draw it out by hand. That's all I'm saying. Okay. And then same as the previous self-assessment, there's a reflection and placing yourself within the rubric as far as your level of understanding. Please make sure that you check the box that corresponds to your level of understanding and the ones under it except for 0. Right, so if you're at a level 3, you click 3, 2, and 1. right? If you only click 3, the initial thing that I see, now obviously I'm intelligent enough, I figure it out. It goes in as a 1 in the gradebook initially before I adjust it. So that's just a FYI. I'll fix it, obviously. I look at all of these individually and make sure that the scores are appropriate and correct. So don't stress too much on it. It's just makes it a little easier. Any questions, comments, concerns? All right. So the suggested due date for this is next Friday, all right? The 23rd. However, like the hard date would be before the end of the next grading period, which is the 6th of November, all right? So it gives you a few weeks to work on this if you want to. However, this is the highest, the self-assessments have the highest weight of anything that you do in this class. All right. So if you need to prioritize, this should be at the top of your list for things to do for my class. All right. The discussion boards and other things, put them off to another time if you're having to pick and choose between things to do. Okay. And that's it. That is our course for today.